Welcome to my channel. I have discussed in detail the differences between comfort cooling and equipment cooling applications, including what distinguishes comfort cooling from equipment cooling and what constitutes a high sensible load application. If you haven't watched that video yet, please visit my channel to view it. Today, I will focus on a crucial feature required in split units for equipment cooling applications. And like comfort cooling, equipment cooling requires operation during winter, meaning units must run in cooling mode even in very cold weather. In regions with extremely cold climates, operating an air-cooled air conditioning system outdoors presents unique challenges. To understand how low ambient cooling units work, imagine you are tasked with designing one yourself. Start by considering the specific challenges and requirements that come with creating a cooling unit that operates efficiently in low ambient temperatures. During wintertime, outside temperature is very low and compressor has to work very less. Power input required is very low. But one major issue is maintaining head pressure. What is head pressure? Head pressure, also known as discharge pressure, in air conditioning equipment refers to the pressure of the refrigerant as it exits the compressor and enters the condenser. This is a critical parameter in the operation of air conditioning and refrigeration systems. When the ambient temperature is very low, the refrigerant pressure will also be very low, leading to inadequate cooling performance. Additionally, there is a risk of liquid refrigerant returning to the compressor, known as liquid slugging, which can result in inefficient operation and potential system failure. Since the temperature is very low, the condenser fan should not run at full speed but should operate at a reduced speed. Additionally, wind blowing into the unit can cause the condenser fan to rotate, which could also lead to issues. In contrast, for low ambient heating units, the fan should operate at maximum speed. I will discuss low ambient heating units in a different video. What kind of challenges equipment manufacturers are facing? 1. Maintaining adequate system head pressure during very cold weather. 2. Possible liquid slugging of the compressor, resulting in compressor failure. 3. Migration of refrigerant into the compressor oil sump during the off cycle. 4. Wind effect on the condenser during very cold weather. 5. Fluctuating cooling load conditions and heat gain in the summer versus winter. When selecting a split unit or any other unit for equipment cooling applications, make sure these issues are adequately addressed to ensure reliable and efficient operation. Mitsubishi Electric has introduced P-Series and other low ambient cooling units to overcome these issues. Let's understand what features available on low ambient cooling units. 1. Maintaining adequate system head pressure. The system's microprocessor monitors the ambient air temperature, condenser outlet refrigerant pipe temperature, and 6 other sensors throughout the system. This information is used to modulate the condenser fan's DC motor speed and operate an electronic hot gas bypass valve as needed. Please see the diagram on the slide. I have highlighted sensors in red. In a standard cooling units, these sensors are not available. 2. Preventing liquid slugging of the compressor. Liquid slugging, which can cause catastrophic compressor failure, is prevented by a high-capacity suction line accumulator that ensures any liquid refrigerant does not reach the compressor. Additionally, self-regulating heaters and an insulating blanket are installed to further protect the system. In low ambient cooling units, accumulator is a must. Please see the picture on the slide. I have highlighted in blue. For standard units, accumulator is not available. This is better way to compare unit. You can make sure selected condenser has accumulator. 3. Avoiding refrigerant migration. A factory-installed crankcase heater circuit is energized during the compressor's off-cycle to prevent liquid refrigerant from migrating and condensing in the compressor oil sump, thus preserving compressor bearing lubrication and preventing premature failure. 4. Mitigating wind effects. To counteract the impact of wind on the condenser, especially during cold weather, Mitsubishi Electric provides windscreens designed to block the wind while allowing adequate airflow. These windscreens include fan coil and side sets, along with a blocker plate to account for prevailing winds. They are designed to ensure no performance derating occurs during summer months and are pre-drilled and painted to match the unit for a factory fit appearance. In installations where the condensing unit is outdoors in an exposed and unprotected location, additional wind protection is necessary. The slide displays the front, rear, and side wind screens. A wind blocker is necessary only when there is a strong wind coming from one direction, and you want to block that specific side. 5. Managing fluctuating cooling loads. In any room, heat gain and heat loss is different at any given time. Mitsubishi's variable capacity inverter system with an electronic linear expansion valve matches the system's BTU output to the heat gain in the space, providing tighter setpoint control and improved dehumidification. This reduces on-off cycling, extends compressor life, and includes a soft start feature to lessen the stress on the building's electrical supply. You may have heard the term inverter frequently. But what does an inverter compressor mean? It refers to a compressor whose speed is controlled by varying the frequency of its power supply. This allows the compressor to adjust its capacity from 10% to 100% of its full capacity, resulting in very high efficiency. Now you may have understand, it's not just wind screens on a cooling-only unit. There are special hardware and software to overcome these issues. If these features are not available, life of the cooling unit will drastically reduce. Thank you for watching. Welcome to my channel MITS HVAC. This channel is for everything heating, ventilation, and air conditioning. Whether you're a designer, engineer, or aspiring HVAC technician, or simply curious about heating, ventilation, and air conditioning systems, you've come to the right place. Our channel is dedicated to providing high-quality, easy-to-understand educational short content that covers all aspects of HVAC technology. Join us as we dive into comprehensive tutorials, step-by-step guides, and real-world demonstrations to help you master the skills needed in the HVAC industry. From basic principles, design of HVAC systems, troubleshooting tips to advanced techniques, and the latest industry trends, we've got it all covered. Subscribe now and stay updated with our latest videos to enhance your HVAC knowledge and skills. Let's learn, grow, and excel in the world of HVAC together. Don't forget to click the like button if you enjoyed the video, and leave a comment below to share your thoughts and feedback. Your input is incredibly valuable to us and helps us create better content for you. Thank you for your support.